So these live loads are gravity loads. Other than dead loads include items such as occupancy by people, movable equipment, and furniture within the buildings, stored materials such as books, machinery, and snow. So for live load, we will be using we will be using IS 875 1987 Part 2. Here they have made a two category. One is live load for floors, or one is live load for roofs. Okay. So for floors, we will be referring IS 875 1987 Part 2 on page number 7. So for roofs, so we will be referring it on page number 13. So if you open IS 875 Part 2, see if you see that table 1, so imposed floor loads for different occupancies. If you are designing residential buildings, okay, in residential buildings, all rooms and kitchens should have a live load of 2 kilonewton per meter square. Toilet and bathrooms 2. Corridor, passages, staircase, including fire escape storerooms, for which it is 3. Balconies 3. So this is for residential buildings. Similarly, there are many values available based on the different occupancies. So next is dwelling units. Similarly, hotel, hostels, boarding houses, lodging houses, dormitories, residential clubs, okay, garages. So in the first you will see the residential building definitions. See, residential building. These shall include any building in which sleeping accommodation is provided for normal residential purposes with or without cooking or dining or both facilities. It includes one or multi-family dwelling, apartment houses, lodging or rooming houses, restaurants, hostels, etc. Dwelling means these shall include any building or part occupied by members of single multi-family units with independent cooking facilities. Okay, these shall also include apartment houses, flats. Next, storage buildings. So you can refer the definitions. Business buildings, office buildings. So office buildings, the buildings primarily used to be used as an office or office purposes. Okay, so your banks, post offices, or comes under office buildings. Similarly, you have institution buildings, college, schools, or comes under institutional buildings. So you can refer this for live loads. This is for live load on floors. So live load on roof. See, for which table 2 imposed loads on various types of roofs. If the roof access provided, then the live load has to be taken as 1.5 kilonewton per meter square. See here, you have a building like this. So this is your roof. If there is a staircase provided, which means access provided, then the live load is 1.5 kilonewton per meter square. So access not provided except for maintenance. If this staircase is not provided, then the live. Okay. Okay. So if you refer IS 875 part 2, this table 1. So table 1, imposed floor load for different occupancies. If you are designing residential building, so in residential building, all rooms and kitchens should have live load of 2 kilonewton per meter square. Toilet and bathrooms 2. Corridor, passages, staircases, storerooms should have 3 live load. Balconies 3. Okay. So this is for floors. There is a separate table available for roofs also. So residential buildings. So you have educational buildings, which means schools, colleges comes under educational buildings. So classroom and lecture rooms should have live load 3. Okay, dining rooms, cafeterias and restaurants live load 3. Offices, staff rooms and lounges 2.5. Okay, projection rooms 5. Okay, these projections rooms are used as assembly purposes, so there may be high live loads. Kitchens 3, toilet and bathroom 2, storerooms 5. Okay. Libraries. So stack room, stack area, which means collection of books. So it is 6. Reading rooms without separate storage, 4. Reading rooms with separate storage, 3. Okay. Corridor, passages, lobbies, okay, 4. So this is for educational buildings. Next, institutional buildings, assembly buildings, okay, businesses and office buildings, so post offices and banks are businesses and office buildings. Okay, so first you can have the definitions here. So here there is a definitions for business buildings. These shall include any building or part of a building which is used for transaction of business. Okay, office buildings, what are educational buildings, dwellings, storage buildings, industrial buildings, institutional buildings. So first we can have the definitions. Okay, so table 1 will guide us to have the imposed floor loads for different occupancies. Similarly, for roof lie load, for roofs in table 2, see here. So table 2, imposed loads on various types of roofs. If the roof is provided with access, then it is roof lie load is 1.5 kilonewton per meter square. Access not provided except for maintenance, it is 0.5, which means you have a building like this. So this is your roof floor. If the access or if the staircase is provided for roof, then you have to use live load of 1.5. Okay, if access is not provided, on which case access not provided except for maintenance, then you need to use 0.75. Okay, if your roofs are sloping, see here, this is for flat, sloping or curved roof with slopes up to and including 10 degree. So if this slope is up to 10 degree, so these two values are valid. If the sloping roof with slope greater than 10 degree, if this slope is greater than 10 degree, then you need to use these values. Okay, so initially for RCC buildings, okay, the slope is less than 10 degree, which means your flat and sloping. Flat means this type of roofs for your RCC building roofs. So you may use 1.5 if access provided. If access not provided, it is 0.75. Okay. So next is staircase load. staircase load. So in staircase, dead load includes self weight of stair slab, which means waste slab, weight of floor finishes, and weight of railings. If you modeled your waste slab as a part of your model, then self weight of waste slab is automatically calculated by the software based on the thickness of waste slab. So for staircase, we consider dead load of 2.5 to 3. We consider 2.5 to 3, which means it is weight of steps, which means weight of riser and thread. So 2.5 to 3. So self weight of waste slab, it is automatically calculated by the software based on the thickness. So for live load, for staircase live load, if it is residential building, we will be using 3. If it is a public building, we will be using live load for staircase as 5. So public building means assembly buildings, institutional and educational buildings. Okay. Now we will see how to assign these loads into our ETABS model. Did you understand the load calculation, or do you have any doubts? Okay. Shall I proceed for load application? No, no, it depends on your project. Here I have demonstrated an example. See here. So this is for example. If you are designing a building, there you may use 600 depth beam. So which means your beam it depends on the site formwork size. Minimum you may use 9-inch beam also. On site you will get a formwork for 9-inch, or in some cases you will get 8-inch also. So 9-inch means 0.23 meters, 8-inch means 0.2 meter. Assume if you are using a beam size of 0.6 meter, in your case floor to floor height is 3.5. In your design for residential building, floor to floor height is 3 meter. Assume you are designing other than residential, any public building. So if your floor to floor height is 3 meter, so in this case, what is the wall height? So 3.5 minus 0.6. What is the answer? 3.5 minus 0.6. What? 2.9 meter your height of wall. Okay. Your wall thickness is 0.23. Assume you are using 9-inch wall. So then your wall load is 2.9 multiplied by 0.23 multiplied by 20. What is the load you should assign? 2.9 multiplied by 0.23 multiplied by 20. What? 13.34 kilonewton per meter. It depends on your project to project. So this is the example I've taken to demonstrate how to calculate the wall load. Okay, so now we shall see how to assign these loads on our ETABS model. So first you open your ETABS model. Okay, so this is the model I was explaining in the session 3 and 2. See here, I forgot to mention one thing while I was explaining replicate option. See here, assume this is your first floor, this is your second, and this is your third floor, and this is your roof floor. Once you complete your modeling of first floor, you can directly copy all the elements from first floor to roof floor by using the replicate command. I will show you how to copy from one floor to another floor. See here, you go to plan, you go to first floor. So now I am in first floor. Okay, first floor. You select all the elements. You select all the elements. You go to edit, replicate. Here you select story. See, replicate on stories, which means you are working on first floor. Whatever the model which is present in the first floor has to be copied for roof floor. So replicate on stories. You need it on same floor, same area, same elements on roof. You select this roof here. If you want to delete the original, which means source, you can check this. Okay, so I will uncheck this. So click on apply. Okay, so now you go to 3D view. See here. So initially there was nothing in the roof floor. So now you will get the same as in the first floor. So you go to plan, you go to roof. See here, this is your roof floor. So now I will copy so I will go to edit, replicate, story. Okay, first I have to select all the elements on the roof. See, on the ground floor also nothing is there. So I will select ground floor, all the elements in the roof, and I will select replicate on stories. It has to be replicated on ground floor. You click on apply. See here, you will get same floor, same material, same elements in the ground floor as that of roof. Okay, so on the ground floor, which means your plinth, I don't need any slab, so I will be deleting these slabs. Okay, so this is your final model. This is your final model. So I will show how to assign the loads. See here. So we would be applying our loads in three ways. Okay, one is point loads or concentrated loads, which is measured in kilonewton. Next is uniformly distributed load or line load. So unit kilonewton per meter. Next, area loads. So unit is kilonewton per meter square. Okay. So in ETABS, line loads are also called as member loads. Not member, frame loads. Area loads are called as shell loads. Okay, so point loads unit will be kilonewton, frame, which are nothing but line loads in the form of UDL, uniformly distributed load, so unit kilonewton per meter. Area loads, which will be assigned on shells or slabs, call it as shell loads, unit is kilonewton per meter square. Okay, so what is the wall load we calculated? So it is self weight of main wall 11.73 kilonewton per meter. So 11.73 kilonewton per meter. How to assign these loads on the beams? So assume these beams are carrying main walls. Assume these beams are carrying main walls. So first you select all the beams. You select all the beams. Okay. So total how many beams? 1, 2, 3. Opposite side 3, 6, 7, 8, 9, 10. See here. At the left corner, you should see 10 frames selected. So you go to assign frame loads. You select distributed. Oh, sorry. So before assigning to any load, you should create load pattern. You should create load pattern. So here you have to create two load patterns. One is dead load and another one is live load. Okay, so how to create load pattern? So you go to define. So load patterns. So by default ETABS will have dead and live load. By default, ETABS will have two load patterns. One is dead and another one is live. So on dead load, self-weight multiplier 1. On live load, self-weight multiplier is 0. So here you need to remember one thing. Don't put self-weight multiplier as 1 other than dead. Okay. So if you put self-weight multiplier as 1 with the live, what will happen? In dead also it will calculate self-weight, and in live also it will calculate self-weight. So self-weight value will be get duplicated. So you need to use 1 only for dead. So 0 for live. So self-weight means own weight of slabs, beams, columns. It will be automatically calculated by ETAP software itself. Okay. So how to define the load pattern? So you go to define load patterns. So dead, live. By default, there will be two, dead and live. So ensure self-weight multiplier 1 for dead, 0 for live. So you click on OK. Now you created the two load patterns. One is dead, another one is live. Okay, once you create the load pattern, you select these beams. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You select 10 beams, which means those whatever the marked 10 beams are carrying main wall loads. So what is the value of main wall load? I think 11.73. So you go to assign frame load distributed, which means UDL. So in the beginning I told you whether your wall load comes under dead load or live load. Dead load. So load pattern name, you should select dead here. Load pattern name, you should select dead here. So direction of load application, you should have gravity, which means downward direction. Which means downward direction. Okay. You use the value 11.73. 11.73. It will work as calculator. Here only you can calculate. So wall height, what is the wall height? 2.55. See here, 2.55 multiplied by 0.23 multiplied by 20. So it is 11.73. So here there are three options. Here there are three options: add to existing loads, replace existing loads, delete existing loads. So first you select add to existing loads. First you select add to existing loads. Later I will explain one by one. So you click on apply. Okay. Okay. So the selected beams are assigned with a dead load of 11.73. See here, on above the beam you will receive a value 11.73. 11.73. Or else you can click this beam, click on this beam, you click mouse right button. So you go to loads. See here, under dead load pattern you have load 11.73 kilonewton per meter. Okay. If you select this beam, if you select this beam, you select and mouse right click. So loads none, because you have not assigned any load. It is showing none. Okay. This is how you can assign the loads. So if you see the 3D view, if you see the 3D view, it will look like this. The load will look like this. So you go to display, undeformed shape. Okay. So you go to plan, ground floor. How to view the assigned load? You go to display, load assign, frame load. So load pattern dead, apply, okay. See here, on the periphery of the beams, you have assigned 11.73. So how to delete this load? Because assume I don't want to assign any load on this beam. How to delete this load? Very simple. You select this beam, go to assign, frame loads, distributed. So this load is under dead load. You should select dead here. You use this option, delete existing loads. You click this option, delete existing loads. You click on apply, okay. See here, on these two beams you have 11.73. On this beam nothing is there because you deleted the load. If you right click on this beam, you have 11.73. Okay, on this beam under loads column, none. Is it understand how to delete the load? Okay. Suppose for this beam, it has to be assigned 20 kilonewton per meter. This load on this beam, I have to assign 20 kilonewton per meter load. By mistake, I assigned 11.73. So what is the difference? 20 minus 11.73. What is the difference? What is the difference? 20 minus 11.73. 8 point. Okay. The difference is 8.27. See here. You select this beam, go to assign, frame load, distributed. Okay. So what is the difference load? 8.27. You click this option, add to existing loads. If you select this option, add to existing load, so software will execute like this. Your original load is 11.73. It is your existing. This is your existing load. Okay. Your option is add to existing load. How much you are adding? 8.27. So 11.73 plus 8.27. So it should be finally 20 kilonewton per meter. See here. You select this add to existing loads under dead load only 8.27. You click apply. Okay. See here. This value has changed. because your existing load was 11.73 and your additional load is 8.27. It will add these two and it will assign 20. Okay. Okay. If I want to assign a load of 5, if I want to assign a load of 5 kilonewton per meter instead of 20, I need to assign 5. So you select this beam, go to assign frame load distributed. Okay, here you select 5. Here you select 5 under dead load direction. It should be always gravity. Okay, you select this option, replace existing load. See, the software will interpolate like this. Your existing load, is 20 kilonewton per meter on beam. You took option replace existing load and you are assigning load of 5 kilonewton per meter. Now tell me what is the final output you should get? What is the final output you should get? My question is whether you will get 20 kilonewton per meter or 5 kilonewton per meter or 25 kilonewton per meter. Which is the correct? What is the final output? Here your existing load is 20. Your command is replace existing load and add 5. What is the final output you should get? Can anybody answer this question? Yes or no? What is the final load you should get on the beam? Okay. So you use this replace existing loads. Click on apply. Okay. See here. So the load is changed to 5 instead of 20. So it is going to replace existing load 20 kilonewton per meter with 5 kilonewton per meter. Okay. I hope you understand. You are able to understand these three options. Add to existing loads, replace existing loads, and delete existing loads. Is it clear? Okay. So this is about frame loads. So I will select all the beams. I will go to assign frame loads distributed. First I will delete all the loads. See here. See here. Here one story and all story. It will work same. One story and all story. So now I am in working in ground floor. See here. I will create a new window. I am in ground floor. So I will choose all stories option here. I will choose all story option. I will select these beams. I am going to select all the periphery beams. You go to assign, frame load, distributed, dead load, added to existing loads. So it is 11.73. So I took all stories option. The same load is applied on all the floors. So apply, OK. See here. You go to 3D view, go to display, load assign, frames, dead, apply, OK. See here. You will get same load on all floors because I took option as all story. Okay. How to assign parapet wall load? You go to roof first. You go to roof first, roof floor. Go to display undeformed shape. Instead of all stories, you select one story. Okay, you select all the beams. Initially, you assign the load as 11.73 because parapet load you need around 4.5 or 5. So you select all the beams, go to assign, frame load, distributed. Okay, you select this replace existing load. So it will replace 11.73 by 5. So if you instead of 11.73 you use 5, you click on apply, OK. Okay. On columns also it has been assigned. So once again you select assign, frame load, distributed. You select only the peripheral beams. You go to assign, frame load, distributed, dead, add to existing loads 5, play, OK. So 3D view, see here. On the floors, you have 11.73. On the roof, you have 5. Okay. So this is how you can assign the UDL, uniformly distributed load, on frames. Okay. Which means I completed assigning main wall, and partition wall. Same. These two are same. And parapet wall. How to assign the loads for main walls, partition wall and parapet wall loads. Next we shall see the area load. Area load or slab loads. In ETABS it is called as shell loads. In ETABS slabs are called as shell loads. So you go to display, undeformed shape. You go to plan any of the floor, first floor. You select one story here. If your story is same means you can go with all stories and similar stories. I already completed the explanation on one story, all story, similar stories. Okay. So assume this is your toilet area. Here you need a sunken slab. On this slab you need a sunken slab. Okay, this is your balcony. Okay, so here live load is 2 as per our IS code, and dead load it is 1.5. Dead load means floor finish. And sunk load, if I am using brick as filler material, it is 6. Okay, so here live load 2, dead load 1.5. Okay, this is same, this slab also same, this same. Okay, this is your balcony. On balcony you have dead load of 1.5 kilonewton per meter square, and live load it is 3 kilonewton per meter square. Okay, first I will show you how to assign the dead load. So you select all the slabs. So 1, 2, 3, 4, 5, 6, 7. So dead load for all the slabs, dead load is 1.5. You go to assign. Here for slabs you should select shell loads uniform. So under category dead load, under pattern dead load, so you use 1.5, add to existing loads, apply. See here, you are able to see the dead load of 1.5. Okay, next for these loads slabs. Okay, live load is 2. You select 6 slabs, 1, 2, 3, 4, 5, 6 slabs. You go to assign shell loads uniform dead load added to existing loads. Now the case is live load. Live load, the load value is 2. Click on apply. Okay, for this slab, cantilever slab, live load is 3. You select this particular slab, go to assign shell load uniform live. Instead of 2, you select load value as 3, added to existing load, apply. Okay, so this completes the shell loads. Here you have sunk load. So sunk load is whether dead load or live load. Dead load. So you select the particular slab. Okay, so you go to assign shell loads uniform. You change the load pattern to dead. So 6, add to existing loads, apply. Okay, see why it is showing dead load as 7.5. On all other slabs it is 1.5. For this slab it is showing dead load was 7.5. Why? Because 6 is your sunk load and 1.5 is your floor finish. So 6 plus 1.5, it is 7.5 kilonewton per meter square under dead load. So all other slabs are 1.5 because these slabs are carrying only floor finish. Okay, how to delete this load? How to delete this load? Same, simple. You go to You first select this slab, particular slab, assign shell loads, uniform, whether you need to delete dead or live. Assume if I want to delete dead load, you select the load pattern dead, delete existing loads, apply, OK. See, if you select this slab, use mouse right click on loads, you have only live load, only live load 2 kilonewton per meter square. So you deleted the dead load. See, for slabs also, these three options works as frames. Same explanation. Add to existing loads, replace existing loads, delete existing loads. So here I want to assign dead load of 2 kilonewton per meter square. By mistake I assigned 1.5. So difference is 0.5 kilonewton per meter square. Okay. So you select this slab. You go to assign shell loads, uniform. Okay, you select this option, add it to existing loads. So load value is 0.5, apply, okay. See here. So 1.5 plus 0.5, it is 2. It is 2. So go to assign shell loads, uniform, dead, delete. Okay, so I'm going to delete all the load. Assign shell load, uniform, live. Is it understood? Frame loads and shell loads. Okay. So next is in ETABS you have a beautiful option called shell uniform load sets. Okay. So assume this is my, okay, we will be consider it as toilet only. So this is toilet. So dead load is 7.5 and live load is 1 point. Live load, what is the live load I used earlier? I think it is 2. Assume this is kitchen. So dead load 1.5, live load 2. Assume this is balcony. Dead load 1.5, live load 3. Assume this is bedroom. Dead load 2 and live load also 2. So you have the beautiful option called shell uniform load sets. Okay. Instead of manually typing in values for every individual slab, you define a named set that contains multiple load patterns at once. See how it will work. So first you go to define shell uniform load sets. Okay. So you go to You go to add new load sets. You write the load set name as toilet. You click add. So for toilet, dead is 7.5. 7.5. You click on add. Live is 2. Okay. Okay. You have the uniform load sets for toilet. You can modify. See here. So dead 7.5, live 2. Next you can add another new kitchen. So dead load 1.5, add live load 2. Okay. Add new. Next you can have the load set name as bedroom. Bedroom. So dead load is 2. Live 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 load is 2. You click on add. So next is balcony. Balcony. So dead is 1.5 and live is 3. Live is 3. Okay. Here you note loads are in the gravity directions. All the loads are in downward direction, gravity directions. You click on OK. See, here we have the different shell uniform load sets for balcony, bedroom, kitchen, toilet. Okay, you click on OK. You select this slab, balcony slab. You go to assign shell loads, uniform load sets. Okay, for balcony, I have created this load set. You can modify. So for balcony, what is the load set value? Dead 1.5, live 3. So okay, apply. So instead of so when you assign a load set to a shell, eTabs automatically applies all the loads defined in that set, which means for this you have dead load of 1.5 and live load of 3. No need to select again and again. If this is your bedroom, you select this slab area, you go to assign shell load, uniform load sets, bedroom, apply, OK. Which means automatically this load set contains a dead load of 2, live load of 2. So toilet, you select this slab, assign shell load, uniform load sets. So toilet, you select this toilet load set, apply, OK. So this is kitchen. Select if all the remaining slabs are kitchen, you select all the slabs. You go to assign shell loads, uniform load sets, kitchen, apply, OK. So this is the load sets, shell uniform load sets option, which is easier. Why? Okay. So earlier we discussed was uniform load. So we discussed uniform load and shell uniform load sets. So this is like unique unique load. Okay. Shell uniform load sets is like which is used for standardized areas like corridor, balcony, parking, decks, and roofs. Okay. So uniform load shell loads and shell uniform load sets. Okay. Did you understand the load assignment, load calculation, and load assignments? If you have any doubts, you can ask me. Okay. What about others? Or else, if you have any doubts from session 2 and 3, you can have the discussion. I hope everyone installed the software. Okay. So tomorrow we will discuss model check, model check, and how to create load combinations. We will discuss how to create the load combinations, and we will try to understand the local axis. We will try to understand the local axis systems. Okay. So is it clear? Okay. I took more than 1 hour 45 minutes. So, but the thing is, in this today's session, while recording, while recording, I missed the dead load calculation. I missed the dead load calculation. I forgot to record the first beginning part of the lecture. Okay. Uh, at the end, I will explain it and record the same, and I will be uploading the video by tomorrow morning. Is it okay? Hmm? Okay, okay. Thank Yes, we missed the beginning part of the lecture, that is dead loads. So under loads we have two types. One is gravity loads, another one is lateral loads. So gravity loads are acting along gravity. So these loads are acting along gravity, whereas lateral loads are acting perpendicular to gravity. So gravity loads are dead loads, live loads. So live loads are referred as imposed loads. So other examples of gravity loads are equipment loads, snow load, and floor finishes. In case of lateral loads, we have wind loads and seismic loads, which are nothing but earthquake loads. So other types are tidal loads, blast load, impact load, traffic loads. Okay, so mainly used for bridge design. Okay, so for dead loads, we follow IS 875 part 1. IS 875 part 1, that is 1987. IS 875 1987 part 1. For live loads, IS 875 1987 part 2. For wind loads, IS 875 1987 part 3. For seismic loads, we have separate code, that is IS 1893 2016 part 1, that is criteria for earthquake resistant design of structures. Okay, first we will discuss the dead loads. So dead loads which are constant, which do not change with respect to time, which means magnitude and load application is constant in the case of dead loads. So magnitude and load Load application is constant. So I have written loads that is fixed in magnitude and position is called the dead load. So examples for dead load are elements self weight. So that is weight of slabs, beams, walls, columns, partition wall, false ceiling, facades, cladding, water tank, stairs, brick fillings. Okay, so next finishes on floors. Okay, that is plaster finishes and other services. So dead weights of different materials are provided in code IS 875 1987 part 1. So if you refer IS 875 part 1, see IS 875 part 1 1987 Indian Standard Code of Practice for Design Loads other than earthquake for buildings and structures, that is part 1 dead loads, unit weights of building materials and stored materials. So in this code you are able to find the unit weights of building materials and stored materials. For example, so density of river sand, it is 18. Okay, next density of aggregates. See now here you find density of cinder. So density of cinder is 7.85. So unit will be kilonewton. Okay, so in part 1 you are able to see the dead weights. So bricks, common burnt clay bricks. So 15.7 to 18.85. Engineering brick 21.20. Heavy duty bricks 24.5. Okay, density of cement. Ordinary and aluminum cement 14.10. Rapid hardening 12.55. For aerated cement concrete 7.45. Okay, density of cement concrete 23.50. Okay, so we will consider it as 24. Next, cement concrete with reinforcement. reinforced with the sand and gravel or crushed natural stone aggregate with 1% of percentage of steel. So density will be around 22.75 to 24.20. With 2% steel, 23.25 to 24.80. With 5% steel, 24.8 to 26.5. Okay, so we will be using it as 25 kilonewton per meter cube. So cement mortar 20.40, cement plaster 20.40. Okay, you can refer IS 875 part 1. So sulfate of slab, beam and column is automatically calculated by ETABS itself based on the sizes. So this is in ETABS, but in StatPro, whatever is modeled in StatPro, the software will take the self weight for it by a simple command. In the StatPro, you need to provide a command. Okay. If the element is not a part of STAT model, self weight will not be calculated. Similarly, in ETABS also, if the element is not a part of ETABS model, self weight will not be calculated. Even though self weight of beam, slab and column are automatically calculated by ETABS, we will see the correct way of calculating the self weight for beams and columns. So if you have a size of 200 by 450 mm, let us assume you have a beam of 200 mm by 450 mm. So unit weight of RCC is 25 kilonewton per meter cube. So first you find the area, that is 0.2 meter multiplied by 0.45 meter multiplied by, so density of concrete RCC, it is 25 kilonewton per meter cube. So you will get 2.25 kilonewton per meter. So which is per meter length, which means this beam 200 by 450 mm will have a weight of 2.25 kilonewton per meter length. Okay, so self weight of beams and columns are calculated as kilonewton per meter. So whereas for slabs, the correct way of calculating the self weight is kilonewton per meter square. For beams and column, it is kilonewton per meter. Why? Because so self weight of the slab is calculated as thickness multiplied by unit weight of RCC. So slab thickness, if you assume 125 mm, so it is 0.125 multiplied by unit weight of RCC 25 kilonewton per meter cube. So it is 3.125 kilonewton per meter square. Okay. So first calculation is floor finish load. Calculation of floor finish load. So assume total floor finish thickness 75 mm. So assume the thickness of floor finish as 75 mm. Tile thickness plus adhesive will have 13 mm. So out of this total floor finish, this part is tile plus adhesive. So it is 13 mm. 1 3 13 mm. So remaining thickness is 62 mm, which means 75 minus 13, 62 mm. So this is your sand or mortar. So this is your cement mortar. Okay. To find the total floor finish load, you need to find the weight of mortar plus weight of tile. So this is tile plus adhesive. So first we will calculate the weight of mortar. So that is floor finish thickness. So that is 62 mm, which is converted to meters here, 0.062 multiplied by unit weight of cement mortar 20. So 0.062 multiplied by 20. So it will be 1.24 kilonewton per meter square. So this is weight of this 62 mm. 1.24 kilonewton per meter square. Again you need to add this weight of tile plus adhesive. So weight of tile plus adhesive, which is 0.246. So plus 0.246 kilonewton per meter square. So finally you should get 1.486. So it is roughly around 1.5 kilonewton per meter square. So generally we use floor finish as 1.5 kilonewton per meter square or 1.8 kilonewton per meter square, 1.2 kilonewton per meter square based on the flooring material. Based on the flooring material. So how I got this weight of the tile? So I have the list of table. Assume if I am using 10 mm thick glazed tile as floor finish, so plus adhesive, its weight coming out to be 0.246 kilonewton. So this is in kilonewton per meter square. If I am using 10 mm granite floor, it will have different weight. So it is 0.346. If I am 12 mm thick using 12 mm thick granite floor, it is 0.4. Okay. See, these granite floor tiles will have higher weight compared to glazed and this porcelain and vitrified floor tiles. Okay. Before going to design, you need to get these details. what is the type of flooring material will be used in the building. So then you can easily work out the loads. If you design it for 10 mm thick glazed tile plus adhesive in the side, if they are using 20 mm thick granite floor tiles plus adhesive, okay, then you will end up in providing lesser loads, because 10 mm thick glazed tile plus adhesive weight is 0.246. For 20 mm thick granite floors, weight is 0.6. Okay. You should, before going to design, you should get the clear details from the site people. Okay. So this is the floor finish load calculation. So next is self weight of main wall. Self weight of main wall. Assume, so floor to floor height is 3 meter, and this depth of beam, it is 0.45 meters. So this much is your wall area consisting of brick. Okay, while calculating the height, wall height, so you need to deduct the depth of beam. So floor to floor height minus depth of beam. So 3 minus depth of beam 0.45, you will get 0.55. And you should know the thickness. Thickness of this wall is 0.23 meters. Okay. So main walls are of two thickness. Either they may be 8 inch or 9 inch. For 9 inch it is 0.23. For 8 inch it is 0.22 meters. If it is made up of brick, then unit weight of brick is 20. So wall height, so this height, wall height is, comes out to be 2.55 multiplied by wall thickness 0.23 multiplied by density 20. So you will get 11.73 kilonewton per meter. Assume instead of brick, if there are AAC block, again you need to note down the density of AAC block, okay, which is less than 20, which is almost 8 to 10 kilonewton per meter cube. So these AAC blocks are light in weight. So if you don't deduct the beam depth here, so you will be providing more weight. So this depth of beam, once already it is considered in self-weight calculation. So instead of deducting this, if we use the full height, so you will end up in providing higher load values, which is not at all required. Okay, so this is self-weight of main wall. Next is self-weight of partition wall. What is the difference between main wall and partition wall? Only change in thickness wall. So your main walls are of 9 inch and 8 inch wall. So your partition walls are 5 inch or maybe 6 inch. Okay, only change in the thickness. Same formula. Height of the wall multiplied by wall thickness multiplied by unit weight of wall material. So assume the beam depth as 0.545. Assume means in site if you are providing 0.45 depth beam. In some cases, if you provide 0.6, you have to take that depth of the beam, whatever you provide at the site. So height of the wall 2.55, thickness of wall 0.5 meter, 20 kilonewton per meter cube, which is unit weight of brick. So here meter cube, this meter get cancelled. Remaining unit is kilonewton per meter. So 7.65 kilonewton per meter. So next is self-height of parapet wall. So usual height of parapet wall is 1.2 meters to 1.5 meters and are of 8-inch thick. Okay. So these parapet walls are provided on roof. Okay. Same height of the parapet wall thickness, unit weight of brick. So height of the wall 1.2 meter, thickness 0.2, density 20. So it is 4.8 kilonewton per meter. So without calculating, we will assume 4.5 to 5 kilonewton per meter as self-weight of parapet wall if it is made up of brick. If it is made up of glass material, if this complete wall is made up of glass or any type of glazed, then you can think of reducing this unit weight. Instead of brick, you can take the density of glass material. Even you will get a load of 3.5 to 4. Before design, you need to finalize these types of material selection and thicknesses. So next is sunk slab load. So where you will provide the sunk slab? So for toilet areas, we provide the sunk slab. Okay. So assume sunk slab thickness is 0.3 meter. If this depth of sunk is 0.3 meters and if this slab is filled with cinder, so unit weight of cinder is 8 kilonewton per meter cube, which is less than brick. So density multiplied by unit weight, so it is 2.4. If the lay person is using brick as filler material, then the weight comes out to be 6 kilonewton per meter square. So here it is 0.3 meter multiplied by 8 kilonewton per meter cube. So 1 meter get cancelled, remaining 0.3 multiplied by 8, which is 2.4 kilonewton per meter square. So whenever I say kilonewton per meter square, it is your slab load. Okay. Whenever I say kilonewton per meter, which is your beam load. So which is assigned as UDL, and this is assigned as shell load or area load. So there may be a chances of you design a slab for cinder as filler material with load with sunk slab load as 2.4 kilonewton per meter square. At the time of casting, they may use brick as filling material. Non-availability of cinders. They may, because these brick bats are easily available. So you design the slab for 2.4 kilonewton per meter square. So at the site they may provide 6 kilonewton. At the site they provide brick bat. Then this is the wrong thing. So before casting, you should ensure these minor checks. Otherwise, you may design sunk slab for 6 kilonewton per meter square. There they can go for cinder or brick bat. You design it for higher loads. They may be using the lighter materials. I have seen using brick as filler material for your sunken slab because this brick bat is easily available. So next is waterproofing load. So it depends on waterproofing material. So waterproofing load will be taken only on roof slab. If this is your building, so this is your base. You have a floors like this. So this is your last roof, which is exposed to weather actions. So this floor, on this floor only, you will be providing waterproofing. Of 2.5 to 3 kilonewton per meter square. So waterproofing load will be taken only on roof slab, so not on the floor slabs, because these slabs are not exposed to rain. Okay, next is live load. I think we discussed it. Staircase. See here. So if you consider this dog-legged staircase, so dead load means in staircase, dead load means it includes self weight of weight slab, weight of floor finishes, and weight of railings. See here. So here dead load includes this weight slab and weight of these steps. So which is riser and thread. Above these riser and thread, we provide tiles. We provide floor finishes. So which is finishes. So these put together are called as dead load of stair. Okay, and live load. So there may be human occupancy, weight of people. It is taken as live load. Okay, so this has to be calculated based on thickness of weight slab, riser and thread, density of finishes. So for any residential building, we take 2.5 to 3. We take it as 2.5 to 3 kilonewton per meter square. Anyway, we will be modeling this weight slab in the ETAP software. So weight of riser and thread finishes. So it will be around 2.5 to 3 for residential building. So in case of live load, okay, for residential buildings, if your staircase is located in residential buildings, then live load will be 3 kilonewton per meter square. If it is public buildings, so live load will be around 5 kilonewton per meter square. This dead load of staircase include railings also. So dead load comes out to be 2.5 to 3 for residential building. So at the sides you may provide the railings like this for the ease of staircase access. So this is the dog-legged staircase. So this is going, and here you have landing. This is called landing, and this is going, and this part is landing. Okay, and these steps. So these horizontal steps are thread. So these vertical are riser. Okay, So these are the various components of dog-legged staircase. Here you may have mid-landing beam. This landing is supported on mid-landing beam. Here you may have mid-landing beam. So we will see the diagram. I'm not able to find the right picture. Yes, here. So this is mid-landing beam. This is your plinth beam. And this is your floor beam. Okay. So your staircase starts like this. You take a turn here, and this is your second flight. So this is your first flight, and this is your second flight. Okay. So I covered the dead load calculation, which I was missed in the earlier part of the lecture. Next you can followed by live load calculation. You can refer to live load calculations. Okay. Thank you.